Thank you, Greta. Thanks for coming. So, again, thanks for being here. My name is Luca Caruso, as she already introduced me. You might wonder why I'm showing you a rhino in front of you. It's definitely, we can take it as a metaphor. A metaphor, as Michel Booker says, a metaphor for big, obvious, and probable risks that are in front of us. And what does it mean, this? Essentially, we are asking ourselves, is this sustainability thing a rhino, a gray rhino? Because people are not really understanding what's happening and maybe are lagging behind about and understanding what are the requirements of being compliant or aligned with the new legislation or the new requirements, for example, of document theft. So nowadays we have several buzzwords going around the web and even when talking to experts. One is cost optimality. Charles is an expert on it. Renovation wave, the recent published document by the government. Lead edge, all this certification. And ZEB with the small letter and the capital letter. EPDB4, embodied carbon, green public procurement, GPP, indoor air quality, ESG. So we have APC and also, last but not least, the document F. In reality, what I'm trying to do today is to simplify the process and trying to make it understandable for most of you. I will be a bit technical, but as well as trying to avoid unnecessary complexity. I don't want to be too simplistic, but I want to, let's say, engage with an elegant simplicity. So it will explain you better what it really needs to be focused on. So today the topic of the lecture is the opaque envelope, because document F, it's very complex and has different chapters in which there are specific requirements. Today I want to give you an overview only on the opaque envelope and also connect with the ancillary concept that can be included in a design that wants to exceed the expectation of a code-compliant building. So just briefly me, and I've been working in Malta for more than 6 years, covering different fields from being a specialist in environmental design to a perito architect, and then as a research officer with Professor Buajar. Now, the structure of the presentation wants to be, so have a little introduction to give you an overview of what's happening behind the scene and also what is the concept, the context we are operating nowadays, and then we go a bit technical. So let's start with the context of sustainability in island states. Essentially, it's known that to survive and to keep on having our wealth and well-being, maintain our wealth and well-being in islands, we have to make sure that we are enough energy, affordable energy, we manage our waste correctly, and we have enough clear water. But at the same time, energy, waste, and water are topics that are concerning construction, and this is worldwide. And so we can see that in construction sector worldwide, according to those research in 2011, 10% of the global energy supply was used to produce building materials. 40% of solid waste stream is associated to construction activities, and the use of water is most of 10%, 12% of use of water, of the global water, is used for construction purposes. So managing those three factors that are, in a nutshell, the pillar of what we call green building, it's already a sustainability issue in a highland and also interconnected with the construction industry. At the same time, most of us are always overwhelmed by the topic of carbon storage, carbon capture, carbon footprint. But there is a problem regarding in sustainability if we leave the discussion only open to the topic of carbon emission. It's called the carbon tunnel problem. The sustainability, it's much wider as a concept. And then we have more aspects to cover. And if we keep on focusing only on emissions, it's just one part of the story. We know, thanks to the evidence provided by Professor Charles Galdias, that Malta it's facing the worst effect of climate change because it's at the center of the Mediterranean Sea. And the Mediterranean Sea is a hotspot for climate change. What we are experiencing now, and the projection up to 2050 are that those, let's say, those events, meteorological events can worsen. So we have increased air temperature, for water, sea level rise. So there is a, how can I say, a collection of potential events that are hitting the Mediterranean, and Malta is at the center. And what is surprising is also that there are higher probability of increasing air temperature, but at the same time, there are lowering also wind speed and the rainfall. So it's a problem of having in a highland, knowing if we have low rainfall, where are we getting the water, potable water, etc. So there are a lot of problems interconnected that climate change is kickstarting. Also, again, Malta is a cooling dominating country, which means that we can no longer focus only on concept like U-value, simply because, yes, we have to cater for winter behavior of the building through the legislation and the document F. But in reality, we should also consider dynamic effects that are more pertinent to a cooling dominating country. And as we can see, Malta is the hottest country in Europe, having the highest number of cooling degree days, and specularly is as opposed to the heating degree days. So the demand of heating load is definitely lower. Now we are living in the post-carbon era. And what does it mean? I was born in the 90s, and I realized that after doing for several years now this job, I realized that the topic of sustainability in building construction is well established, as more than 30 years. Because here you can see that in 1990, we have the first IPCC assessment, but then also the first edition of the BREEAM green rating scheme. Then we moved later in 1995, we have passive house, and in 1998, thanks to the knowledge developed in England, the development of the first edition of LEED. So thanks to the accumulation of this knowledge, it comes without surprise that the European Union decided to take the lead on those topics, at least on energy performance, and launched the first APDB, the 2020 package. Then it's been a landslide because we have the second amendment in 2010, the famous COP21, which established, the legally binding agreement, and now United States has decided to withdraw according to the new government and the new presidency. But we are continuing working on this, and you cannot really stop this wave of sustainability because we have several commitments in Europe to respect. And one of them is the fourth amendment of the Energy Performance of Building Directive. That's why initiatives are flourishing. And it's not only European and national plans, but also there are commercial entities that are trying to cover the loopholes of the sustainability world by issuing new product labels to engage with the topic of transparency. The more transparent we are, the better is for the market. And also we have legal requirements such as the famous APC. But we must always remember ourselves, why are we doing this? And locally, this can be boiled down to main two topics. The fact that 1/3 of the area of those islands of the archipelago of Malta are covered by buildings, and also because we spend most of the time indoors. So these are two topics that, for me, gives you much food for thought to continue working on those topics, because they are very important buildings for us. And it's also important to remind that thanks to the involvement of the European Union and those directives, we have made an advance towards focusing also on existing buildings. It's not only about designing better buildings that are newly built, but there is a mandate to focus most on existing building, because if we look at the life cycle, if we are taking the life cycle thinking approach, we can imagine that there are far less emission associated to the whole construction process and use phase when you just retrofit a building or adapt to new use. Also, this has liberated several new opportunities for creating new jobs, and also to have public building leading by example. This is an interesting graph showing you the end energy use of in Malta. As you can see, again, residential and commercial building are essentially the bulk of the energy uses in Malta. So this, again, is supporting the interest of working to find solutions for residential and commercial building, because even in Europe are the most diffuse building typologies. And if someone of you remembers the little video I launched on the social media when I was promoting this event, I used a particular reference regarding the fact that more than 30% of the buildings in Malta are not built and not designed and constructed to prioritize health and well-being. We can associate this to this graph and this figure in particular. But what I would like to emphasize is that this topic of energy poverty, or in other words, based on three factors: arrears on utility bills, inability to keep home adequately warm, and dwellings with leakages and damp walls. If we look at those three pillars, we are basically dealing with a technical and an affordability topic. It's not something that requires rocket science, and we are not able to do it. So it's important to remind even our government that if we push more on those topics, it's definitely feasible with today's knowledge. And there is another evidence from the long-term renovation strategy, again, substantiating the fact that it's a technical and affordability matter. From the data of EPC in Malta, basically it was discovered that the average U-value of the walls are 1.88, and nowadays we have a restriction on U-value at 1.22. Again, these are average figures, of course, derived from the various type of assessed building typologies. Windows are unfortunately still quite high, even though they are not so far from the limits of the document F. And what surprised me is the inefficiency also of the roof, notwithstanding a very low threshold for U-value even in the previous version of the document F. Okay, I will briefly go through the topic of energy performance of building and how it is essentially organized in terms of on a technical level. I don't want to, most of you already knows, but it's good to remind ourselves. So we have an open thermodynamic system, and we have different boundaries pertaining, one to the building envelope, another to the heating plant or the system in general, and then we have to provide energy. So this is the direction. So we have the very first source of energy, the primary energy that comes from the power plant. Then this is distributed through the grid. And we have a first inefficiency when we pass from the creation of the energy from the power plant through the grid. So we have the loss. And that's why we associated emission factors. Then this amount of delivered energy gets, it's served throughout those boundaries. And essentially, throughout the process, the flow chart, we see that we ended up having several losses. And in the case of heating loads, there is this relation that is similar also to the cooling side of the story. So transmission losses plus ventilation losses minus passive solar gain plus internal gains. In summer, the problem of internal gains becomes a gain. So we need to remove, and then so we switch the two factors of the equation. So we can also assign a direction of the efficiency towards low carbon buildings. And we can see that if we improve the performance of the boundary of the heated zone, is the first action you can take to improve your energy efficiency. So the thickness of this arrow must be reduced, okay? And it can be also helped by the internal gains. As a cascade effect, then you will be needing less delivering energy, to keep the same equivalent level of comfort indoor. And then also the same demand, the energy demand, and the energy needs will be definitely lower. So we will be having less carbon emission in a nutshell. So the famous Trias Energetica, also promoted by the CO2 project by Charles, always support this step. Step one, passive design strategy, so working in where the architects are playing the most important role. And also, I must emphasize the fact that we can also prioritize the overall environmental comfort, which means thermal, acoustic, visual, and air quality. Then, once the envelope is well designed and airtight, we can just, our energy needs will be lower. So engineers will help us in, providing and sizing only what is needed to provide the level of comfort. And then we won't need big, for example, photovoltaic fields to have an NZ building in Malta. We will just cover the net demand that is necessary to cover. Passive and active system, what is passive? Passive are working on building materials, specification, so thermal conductivity, specific capacity, etc. Dimension and orientation, window to wall ratio, shading devices, insulation, glazed area, of course. And then active, okay, system-based, so heating and cooling, plug-in loads, renewable energy, sources of energy. So these are the two main disciplines in architecture and construction are getting together to support energy efficiency and sustainability in general. I will briefly remind you the passage, what is currently a legal requirement, because as I was saying, in 2002, we had the first EPDB at European level. And now, after 22 years, we have the Fourth Amendment. So there is so we are encouraged by the European Union to continue working on this. And also the Second Amendment introduced the concept of nearly zero energy building, NZEB. And the Third Amendment was raising attention on major renovation. These are the topic that the directive, the Third Amendment, was insisting upon. Essentially, the smart readiness, the cost optimality, and the existing building, and also knowing what is a major renovation, what are the conditions to define it, and also impose stricter requirements. In Malta, Malta joined the European Union in 2006, so it was still lagging behind at the time. Now it's trying to get back on track. So we see that in 2018 there was a rush to implement the EPDB2. To be honest, I don't know now what are the plans for the Third and the Fourth Amendment, but the document F, the new version of document F, is aligned to the second EPDB. The zero energy building is a building with an extremely low amount of energy that is needed to cover the needs, and the demand of energy should be also provided most of the time by renewable sources that are on site or nearby. And also, the major renovation is a very interesting topic, because once we get an existing building, you might have to perform even little intervention. Then it doesn't make sense to charge you with requirements that might become very expensive. But when your development is more extensive and more needs to be, maybe you want to have a deep renovation of it, then the limits are from the law 20%, either 20% of the volume of the building that is changing. The works are affecting 25 or more, 55% or more of windows or roof, so the building envelope. This is instead another factor to demonstrate major renovation, is that you are changing more than 20% of energy consuming installation, or simply a change of use. And we have this urgency to comply with standards. But in my opinion, sometimes it's always good to remind why we are doing this. And we are eventually doing this because we want to enhance our thermal comfort. Because heating and cooling is mostly related to thermal comfort. But we can also overlap to the other topic of environmental quality, indoor environmental quality. Quindi, let's go into the detail of the structure of document F. Do you have questions so far? It's fine for you. Shall we continue? Moment? Okay. So, most of the parents in this room will know that once you get a permit endorsed, you will have to abide to the building regulation, and even before, but most now from the 1st July of 2024, we have to abide to the technical document def, who has a new version. There are 3 documents, one on specifically focusing on residential building, the other on non-residential building, and the third one on technical service. It's a quite interesting structure because you have to address different problems, and also it gives you an overview of the system. It gives you an idea what you can install as an energy-saving technical system. Okay, and since today we are talking about the opaque envelope, I want to emphasize in a nutshell what are the requirements for the envelope. We have in residential building, this figure here, we have in this case it's for major renovation, we have a limit on 0.59 limits on U value, and similarly for exposed floor, we have 1.57. Okay. So the exposed wall, this is not. Sorry, new buildings. 1.57 for major renovation, as opposed to 1.22 for new buildings. And then also you have non-exposed floor. Then there is also a requirement on windows, but it's quite easy to demonstrate that you are complying with this grid. Tell me.
Observation. I know it is from
Sì.
There's a mismatch between the roof. The upper drawing says 0.59.
Sì.
And then there it says 0.4.
The lower one is for non-residential.
Okay.
Because the government is saying that probably it's much more important to protect roof to have a.
It's a mistake in the drawing.
But it's legal, so I mean,
Yeah,
anyway.
But they have put a small note. There's a note. A really small note that says that should be 0.4.
But even for residential, you mean?
Yeah.
Ah, okay. Anyway, consider that to get to 0.59 or 0.4, you need at least 10 centimeters of insulation. You cannot expect. You cannot do it with less. The topic of U value revolves around mainly 2 parameters, material parameters. One is the thickness, and the second is the thermal conductivity. Here, you calculate the thermal conductivity from the ISO 6946. You sum all the thermal resistance. You sum all the resistance of each layer of the envelope, and simply you get the final U value. And then you repeat this for all the walls, roofs, exposed floor, non-exposed floor. To be precise, non-exposed floor has a much more complicated equation because it tends to take into account also the interaction between the terrain and the wall, and this is typical for basement or semi-basement. Yes. Exposed to the outdoor environment. Non-exposed, it's the ground slab.
Or to an unconditioned space, like a garage.
An unconditioned space, yes.
Or stairs.
Okay. So that's those spaces that are unheated, so you don't want to have a direct control on the temperature, and also the outdoor environment.
So the thermally unconditioned spaces are considered as being outside of the building, like outdoors, in terms of
they are dealing with different stimulus. It's not the same as the outdoor, and essentially it's just a different level of requirement that you have to abide with. Definitely, I think who did this part of the committee, they were saying maybe the contact with the ground The outdoor stimulus is not as variable as the outdoor one, so because the terrain tends to be seasonally stable at a specific temperature, but then we are not seeing the content of water, and that is another can of worm. But in any case, they were saying the variation are mild when in contact with the ground, as opposed to the outdoor environment that are more variable. So you need a stricter requirement for outdoor elements, for elements exposed to the outdoor elements. So again, what I wanted to say is that this is extract from a project we did with Professor Boager and part of my PhD research. Just to give you an idea, a non-insulating material is concrete and has 0.8 watt per meter Kelvin thermal conductivity. An insulating material like polyurethane foam has 0.04. So you see the difference of the level of magnitude between the two parameters. Okay, let's make a step forward. Document F has included a database of material properties that are indicative for you to start your assessment, but they need to be replaced once you decide what material are you really installing in your building. But in that list, it's also included the density and the specific heat capacity. Thanks to these two other material property, we can tap into the ISO 13786, and we can also study the dynamic parameters of building material. If thermal transmittance is a steady state metric, we can implement the so-called periodic thermal transmittance that incorporates in its definition two aspects: the time and also the way you position the building material within the assembly. Okay, because this has an immense difference on the behavior of the thermal mass. So you can even decide, according to how you're going to use the building and the type of building, really, I don't need a thermal mass, but I need to heat up and cool down the building faster. I put the insulation indoor, as opposed to the most recommended solution to have the insulation on the outer skin. And simply, the periodic thermal transmittance is defined by the ratio between the heat flux, the indoor heat flux, this blue curve here, and the outdoor temperature. Those are two sinusoidal relationship, and the phase shift between the peak of the outdoor temperature, the maximum temperature that is usually experienced at noon or at 2 p.m., needs to be delayed by several hours by the peak of the indoor heat flux released, the heat flux released indoor. And this heat flux then essentially will constitute a load, okay? And the more massive, so the higher the thermal mass is, the higher is this time shift between the two sinusoidal curve, okay? And that's it. So it's important to know that this calculation of the thermal mass is not just a random number, a very big number like we have in the EPC calculation, the so-called effective thermal mass. But there is a much easier metric to calculate, to quantify, at least theoretically, the impact of thermal mass that is expressed in hours. And I will show you with examples what it means. Just to give you an idea in terms of density, and keep on having this comparison between an insulating material and non-insulating material, concrete has a density of 1,836 and a specific capacity of 900 to joule per meter square Kelvin. As opposed to the insulation that is typically between 30 and circa 100, 150 kilogram per cubic meter. While the specific heat capacity can be quite interesting, up to 1,300. Now, to show you the importance and the position of the insulation layer and the way you can really change the behavior of the opaque wall according to your needs, I will keep fixed the U value at 0.56, and I will vary the other parameters. And I will show you how the thermal lag and the internal areal heat capacity will change. So in this case, we have the cappotto, a famous cappotto solution, 300 millimeters. Simply a 230 load-bearing wall with an EPS panel, 50 millimeters, the fixing, and of course, render and plaster indoor. So, according to ISO 6946 for the U value and the ISO 13786 for the dynamic parameters, we have 0.5 for the U value, and then we have a thermal lag of 8 hours, more than 8 hours, a Y value, the periodic thermal transmittance of 0.12, and an internal aerial heat capacity of 57 kilojoule meter square per Kelvin. If we opt for a double leaf wall, okay, 230 ACB internally, 50 millimeter EPS, and limestone leaf of 180, we have still U value of 0.5, but the thermal lag is skyrocketing to 14 hours. And also, this is also reflected by the periodic thermal transmittance. But the internal area heat capacity remains the same. Why? Because we are maintaining the same the material that is facing indoor, and because of this property, its density, give us this kind of value. Also, it's important to notice the thickness of the wall. To maintain the same level of U value, you are adding 17 centimeter to maintain the same static metric. But then here we are privileging with this option the dynamic effect. So we are gaining more than 6 hours of thermal lag. The thermal lag, in a nutshell, it's the amount of the theoretical amount of hours through which you can expect to perceive the outdoor temperature indoor. So this perception is delayed by this amount of hours. Again, theoretically, because their models might be imperfect, but they are quite good, and I have demonstrated it in another paper that I'm currently writing. And but again, these are walls with another purpose. Sure.
So theoretically, you're saying that it's 14 hours in this case for the thermal lag to start feeling the effect. Will residents start feeling or the perception of a warm, especially in summer, a warmer indoor temperature?
Allora,
Cooling off will take even longer?
yes, it will take longer. Thanks for the question. The thing is, they will feel that temperature, for example, 40 degrees, only if 40 degrees are maintained over the day. But most of the time, we have temperature swings. So the wall won't have that external stimulus to maintain and to transmit that proportionally that heat and then eventually we will be feeling 40 degrees after 14 hours. But the concept behind the thermal lag is this, and the thermal mass in general is this. So the advantage is that having those temperature swings, definitely we will not reach, surely, we will protect ourselves from this kind of events. Sure.
Just a comment.
Sure.
Perhaps the thermal lag of 14 hours
Uh-huh.
could be interpreted that in a real building, like take a terraced house where you have a bedroom upstairs.
Yes.
That's how it is, or top floor. Then if it's, the sun is, say, 2 o'clock in the afternoon,
Yes.
in July, the hottest day, then 14 hours later you are asleep in that room like 4 o'clock in the morning.
Yes, just consider.
Heat lag, would you actually feel the heat?
Yes,
First time or
exactly.
for a bedroom, but maybe for a living room, or we have classrooms in a school, or that it's a different story. So I think it needs to be tweaked for the building type.
Exactly. That's why the powerful of having this kind of assessment right from the start when you design your building, you can really start this conversation with the designer and understand what it needs to be done according to the use of the building. For example, if we consider the winter season instead, the thermal mass will help you in maintaining the comfort, the heat for longer. So it works positively in both seasons.
And when you say thermal lag
Yes.
is that considering a constant outdoor temperature for it to calculate?
Yes. Yes.
You are considering the temperatures outside?
Essentially, the curve, the relationship is always the same. Then the software that does this for you consider the profile throughout the day. But eventually, thanks to the properties.
If you have outside, for example, the outside temperature is below the indoor temperature,
Mhm.
then you would have a reverse direction of the.
Yes, and definitely. But it's not the direction of the heat that matters. Is also what matters is how the wall reacts to those external stimulus. And so this is a theoretical calculation to give you. Listen, if you want to opt.
Important to focus on overheating.
Anche, sì, yes. And again, I'm insisting on this because this is beyond document F, of course. Nobody's asking you to calculate, but it's good to remind that there are opportunities to reflect on the properties of material properties that are already included as a referent element in the document F. And if you can perform this kind of assessment, are very useful if you think it dynamically. Okay, and to go fast on the last option I'm describing, I got rid of two layers, the ACB and the insulation, and I introduced the aerated autoclaved block in 200 millimeters. What's happening? Same U value, thermal lag slightly increased. Why? Because we got rid of an element that is very small in terms of thickness, that is not as thick as the new insulating medium with the aerated autoclaved block. And also, we are getting rid of a block that is it is not a full block. It's an hollow core block. And this has an effect on the overall behavior of the thermal mass. And also the major contribution is also given by the properties of the stone, of course. But in this case, the internal area heat capacity, it's halved. Why? Because the density of the internal leaf is half of the hollow core block. The hollow core block has a density of 1,100 circa, and the load-bearing AAC, it's 600. So again, you can appreciate similarities in terms of U-value. So steady state metrics that are identical, different solution of wall solution, but definitely different behavior in terms of dynamic aspect of the building.
In many cases, the hollow core blocks are specified as filled with concrete, so they're no longer hollow.
Esatto.
And in many buildings, they are specified as double leaf filled hollow core blocks with insulation on the outside.
Okay.
So would you expect the thermal lag to be greater in that case?
Sure. If you do double leaf of hollow core plus the insulation, you might be closer to this solution, because you have quite a decent density on thanks to the hollow core block, plus the 50 millimeter insulation that contributes to the thermal properties, with low conductivity. I cannot tell you how much will be the U-value, but it might be probably in the region of 0.7, 0.8. That's to be calculated. But dynamically could be interesting. Again, but this is just part of the story. Then there are a lot of other questions when we decide not to insulate an element, that has to be considered as well. Again, insisting on insulation, it's important to remind ourselves that if we build a single leaf wall, the calculation gives you the theoretical calculation gives you 1.9, 1.8 ACB, but we measure with Professor Boager, and an ACB, a single leaf ACB, is 2.4 real. And Charles Youssef has a similar paper that reached the same values.
Depends a lot on the manufacturing.
Anche the manufacturing, but yes.
As much as the compressive strength.
But you cannot, I'm not expecting that goes lower than 2. So this is an uncompliant wall. That's a fact. It doesn't make sense to continue building in this way for several reasons. And I'm using this as part of an example of my PhD thesis on the double C block. This is an insulated block. At the center part, it's a 190 block, insulated, and we have 3 centimeters of polyurethane insulation. And this little amount of insulation led us to measure a 1.44 U-value. So here you have 2 references if you want to know more about this research. And this research was conducted before the new enforcing the new document F. So we were still compliant. But now the solution is to simply increase the quantity of insulation in the double C block. And my theoretical calculation with the 2 centimeter, a 230 double C block and 2 centimeter insulation all around, it's in the region of 0.6. Because the central part, it's almost 6 centimeters of insulation, so it's equivalent to the capote. Okay. So far, we have about not caring about thermal bridges is the hygienic aspect, because being preferential heat transfer path might be the ideal environment for the development of mold. So we could have colder spots in the building envelope, especially in winter, and with a high level of humidity indoors and outdoors might be kickstart the condensation phenomenon. And this can lead to black stain, because maybe the particulate matter in the air, but mostly the development of surface mold. So if we don't, especially if the building is heated intermittently, these are things that might happen in Malta in some part of the year. And also, once the mold starts, then it becomes difficult to remove it. So there will be a price to pay. And it's important also to remind that document F, energy efficiency, the debate is only about thermal performance. It's not about hydrothermal performance. And in my opinion, in Malta, hydrothermal, which means considering the impact of vapor dispersed in the air, relative humidity, and the conjunction with the thermal phenomena is definitely something that's to be addressed. In air and moisture models. So this is the whole inclusive assessment that one has to try to consider, at least to make sure you have all your parameters right.
The objective.
Okay, I must say that this is possible to implement what I already said in real projects, and I'm happy to share that I'm working on several ones that are trying to implement those deep assessments, even when you have a very strict requirement like this farmhouse in the north of Malta. Okay. Now let's close the topic of document F, and let's start something that might be new for someone of you. This is called the indoor air quality topic. Indoor air quality is part of the indoor environmental quality. Indoor environmental quality embeds air analysis, daylight, acoustic, and thermal comfort. So it's not new to us, but it's part of the story. And from what we can see here, the source of pollutants, what we believe is a safe environment might not be the case. Essentially, being a very small and confined volume, and we spend most of the time indoor, the truth is that the most polluted environment is the indoor one. So we must shape our habitat in a way that preserves our health. Why we are saying the effect of bad air quality indoors are associated to pathologies such as asthma, ictus, and rhinitis, running nose. So it's really something that can trigger problems when you spend so many time, not only in your buildings, but also in offices that are disregarding these aspects. And there are references to which we can use as a again as a reference when to start understanding what it's all about. One is is a certification, is the most famous certification for indoor environmental quality, and it has a concept specific on air. Okay, and what is it important to consider that well tells you to monitor the level of pollutant. The most important pollutant for indoor air quality are particulate matter, PM 2.5, PM 10, inorganic gases, carbon monoxide, ozone, and when we deal with basements, we have radon. In Malta, I knew that there are less effects of radon apparently. There was a study saying that it's not really a problem. But you can also push for enhanced air quality and you lower those thresholds. It's important to point out that those thresholds are monitored when the building is occupied. So to get the certification, you have to monitor the building. So that's why it's called a performance, and it's more about performative, as a more performative approach rather than simply assessing sustainability. And once you have monitored for a year, then you must take action if your building is not designed right to maintain the certification. Then there are the infamous organic gases, the VOC, volatile organic compounds. The most famous is formaldehyde, and again there are limits for that. Out of the VOC list, we have some materials that are chemically listed in the CAS registry with the associated impact in terms of health: Siren, Toluene, trichloroethylene, very strange names with an allowable concentration that has to be monitored according to this standard. So you can imagine when you design a building without monitoring what you might have, you might breathe every day. So as a designer, we are now aware of the impact of our choices when installing building materials or whatever we want to furnish our buildings. And it's a very important decision to communicate to the client. But something that works against designer is the lack of transparency in the use of building materials. And thanks to the evolution of the market and the interest supported by requirements of construction authorities, etc., some manufacturers are becoming aware and are working to be more transparent. And the main two aspects that are being studied are the health product declaration. So it's a certificate that tells you ecotoxicity and the impact on ecotoxicity and human toxicity, but also the overall impact, environmental impact through the EPD, which is connected to the concept of life cycle assessment. And I would like to connect this passage with the local green public procurement standard. And the most important tender that is currently out for bidding is the new acute mental health department at the Mater Dei Hospital. And as part of the tender, the contracting authority has imposed the green public procurement strategy. So there is not a requirement because it's part of an action plan. So I'm not sure if it's just a recommendation, but now that it's part of the contract, then it becomes a recommendation.
It's mandatory if that tender is more than a certain threshold.
Yes.
So it's not just for buildings, it's just even like procurement of vehicles, a percentage need to be electronic vehicles.
Yes.
So it's mandatory oversight. I don't want to.
In fact, the title of the tender is New Acute Mental Health, constructed with environmentally friendly materials and strategy. And so the requirements, if we connect it to the if we connect it to the how can I say the opaque envelope, what we have is that 15% of recycled content, for structural frame, beams, external walls, etc. Even the foundation and substructure. So as you can see, there is this connection in terms of resource efficiency. But also, when you demolish the building, if 55% by weight of non-hazardous waste must be diverted for recycling or reuse. Surprisingly, there are also limits only for paint and varnishes about volatile organic compounds. But this, it's a requirement that is not going into the detail of the single element dispersed in the formulation. But it's just telling you what is the use of the paint and varnish, and you must meet those limits.
Is it a BREEAM or LEED?
No, green public procurement.
No, I mean, but then there, for example, is it?
No. The standard on the sustainability metrics is only the EPC. They are requiring an EPC at the end of the day.
Because of those are controlled by normally BREEAM and LEED.
See, because BREEAM and LEED goes very into detail of different phases, so it's not really partial like the national legislation. Okay, embodied carbon, I will be fast on this. The idea is that we are the growth of well-being and the related economic activity should be disconnected by the resource use. And the more we do with less, the better, and symmetrically even the environmental impact. If we approach the life cycle thinking, then the application in construction, it's quite interesting because construction of buildings has several layers of difficulties. You can have one level of assessment at material level, and you stop at material extraction, material production. These are the modular elements to describe a life cycle assessment. Then, if you opt for assemblies, you are still here, but then you can add the transport. If you want to consider the whole life cycle assessment of the entire building, then you have to move to consider those other categories: space, demolition, etc. It's important to point out that the transport element it's very relevant because the same building, same specification, etc. will have a different impact whether it is built in Norway or it's built in Malta. For this reason, I want to introduce the material pyramid. It's an exercise that was developed by some professionals in the north of Europe, and essentially is based on EPDs valid for Northern Europe and Scandinavia. It is a database, an interactive database of building materials, and through the information gathered from those EPDs, you can see how the various impact categories change the importance of environmental impact of materials. So far there is an interest in the global warming potential. So it's associated with the impact on climate change. Okay? But then, and for example, here we have metals. The most, let's say, the material who impacts the most in terms of climate change related matters are metals, the production of metals. Concrete cells, like in between. And then you have bio-based materials. For example, wooden structure, okay? These tend to be a carbon capture material. But again, if you want, I can show you interactively, but I will tell you because we are running out of time, unfortunately. If I go to acidification, instead of shift from global warming potential to acidification, this pyramid will completely change, and the wooden element will become like, will turn from being negative, having a relevant effect on the acidification potential. So it's important to know exactly what are the scope of the assessment in terms of environmental impact of material. So far, we are again focusing on this aspect, global warming potential. And for this reason, to reconnect to the previous presentation, EDGE is establishing a worldwide database of GWP values, so that you can assess your building according to energy, water, and embodied energy. And to get the certification, you have to be 20-20-20, so 20% efficient in terms of energy, water, and in the use of material. In conclusion, the method I'm envisaging to push for what I already discussed with you, it's definitely to work on the code compliant elements, the pillars, which are energy and water. It's another topic that is very interesting, and it's part of the document F. And essentially, what I propose is to start working first on the building envelope, on the assemblies, to leave enough freedom to do a scenario analysis, so that you can really build your BOQ, your building of quantity. You start having an idea how much this energy efficiency exercise will cost you. And after that, you can combine the results of the assessment, energy efficient assessment on the building elements, and then start having building simulation. A simple building simulation is even the APC assessment at the design stage. But also you can even implement more advanced one, like climate-based dynamic building simulation in terms of energy performance, and also daylight assessment. Once those elements, I mentioned GPP criteria to have a reference on indoor air quality, for example. Once you have that in place, then it makes sense to consider applying for third-party certification, because you already have the bulk of the work of the ground. You have laid a lot of groundwork, so that once you try to accomplish and to be compliant with those criteria, it will be definitely easier, and it's not going to be difficult if you are, as opposed to you are completely disregarding those topics. And essentially, the more we move away from the bulk of concept of green buildings, and we move to the left towards the so-called regenerative buildings, it means that we are working on the single material level, even the embodied carbon, etc., the indoor air quality. But also you can be more ambitious, and then knowing that once it's constructed, the building is not all, everything is not finished there. Efficiency must continue with the proper management. And starting from this, you can perhaps opt for those two third-party certification that are focused most on health and well-being. So in a nutshell, this is, I believe, my vision on how to implement a new green and healthy building, and I hope you enjoyed this presentation. Thanks.